Hi dear friends, welcome to the video. Here in this video we are going to be looking at solving a simple problem on moment which enables you to understand the problems on moment in a very easiest way without any confusion. So without any delay, let's get started. So you can see the question on the screen, which is representing four forces in four different colors with four different magnitudes in four different directions, right? And all the forces are separated with a distance of 2 meters from each other, and we have 4 points: point A, point B, point C, point D. So in the question he is asking us to find out the moments acting at each and every point A, B, C and D caused by 4 different forces. So without any delay, let us get started, and I hope this will enable you to understand in a more better way. Let us choose a second page. Before getting started with the answer, let us paste the question here in our page. It would be easier for us to access. Wait a second. I'm selecting the whole question and I'm gonna copy it. I'm gonna paste it here in the second page, and I'm putting it in the at some distance here, right? So let us find out moments at each and every point. First of all, let us point moment at point A. Moment at point A can be found here in this sheet. So moments of point A equals to, we have to consider all these forces so that moment at point A can be obtained. So moment at point A equals to, let us write all the forces. All the forces with respect to A are acting in clockwise direction. All the forces, not only a single force. So no force is acting in anti-clockwise direction. So all the forces can be taken as positive. Let us write each and every force first, and later we will be adding up all the moments. So what is the formula for moment? So m equals to force multiplied by the perpendicular distance between the line of action of force and the point where the moment is required, right? For example, if I take this point, so at this point I wanted to calculate the moment. So force is somewhere acted here, right? If the force is acting here, this is the point where I require the moment, and the line of action of force will be like this. If I calculate the perpendicular distance, this is nothing but perpendicular distance between the point where the moment is required to the line of action of force. This force F, when multiplied with distance x, this will give the intensity of moment regarding with respect to this force with respect to a point caused by this force with respect to point A. This is the way how to find out the moment. So in this way we are going to find out. So here, how many forces are there for point A? For point A, there are, for this point A, in this picture it is clearly mentioned that there are 4 forces are acting. So let us write all the forces. First of all, 60 newtons, 60 multiplied with the distance. Let us write distance. So distance I am leaving it emptily, so later on I can write it. So 60 plus 70 into distance plus, I am writing here in the down, and 40 into distance plus 30 into distance. What I have done is I am calculating the moment caused by each force. So moment is caused by the force along with the distance. If the distance exists between the line of action of force and the point where the moment is required, then only moment also exists, right? If the distance is 0, moment also will be 0. So let us try to crack. So for this point A, so this is point A and this is 16 newtons force. 16 newtons force. So what he is asking is, what is the moment created by this force 16 newtons? So let us draw the line of action of force. This will be the line of action of force, right? And what is the point where we require the moment? This is the point where we require the moment. And now, what is the perpendicular distance between this point and this uh, this line of action of force? Point and this line of action of force. There is no distance between the point and line of action of force. The point is directly lying inside the line of action of force. So the distance is 0. Let us write it inside. Wait a second. I will change the color. What is the distance? Distance is 0. So go for the second force, which is 70 newtons. Here let us write point G. And 70 newtons is acting here. And what is the distance between 70 newtons and point G? So let us write the line of action of force of this force. It will be like this. It will be continued, and the straight line which I have drawn here, the straight dotted line, that is nothing but line of action of force. Line of action of force is also passes through the force itself, so it is not needed to indicate the line of action of force within the force. So what is the perpendicular distance between point A and line of action of force? That is 2 meters, which is already given in the question. So here I am going to write it. So here it is 2 meters, and the force intensity is 70 newtons. So distance is 2 meters. So it can be clearly seen that each and every force is separated by a distance of 2 meters, right? So it is 2 meters, right? And coming to this 40 newtons, this 40 newtons, so this is point A, and this is where force 40 newtons is being acted. So I'm considering from this picture. So what is the distance between, is there any distance between point A and line of action of force? Yes, there is a distance, that is 2 meters. So let us write 2 meters inside the box. Okay, fine. It is 2. And another force 30 newtons, which is completely acting towards in upward direction. And this is 30 newtons. And where is point A? Here itself point A is also there. So what is the distance between line of action of force of this force and the point where the moment is required? Point J is the point where the moment is required, but point J is directly lying inside the line of action of force of 30 newtons force. So there is no distance between them. So that is 0, right? Let us write it along. It is 0. Let us try to find out the total moment acted at point G by these forces. Moments at point J equals to 60 into 0, it is 0, plus 70 into 2, it is 140, plus 40 into 2, it is 80, plus 30 into 0, it is 0. So that equals to 140 plus 80, that is 220. And what is the unit? Forces here are measured in newtons. When it is multiplied with the distance, it becomes meters. So the intensity of the moment at point A, when all these 4 forces applied, it is 220 Newton meter. In the same way, let us also find out the moments at point E. Let us paste the question here. Let us resize it. Let us take it, drag it here, and go for point B. Let us try to find out the moments at point B. So moment at point B. So previously we have mentioned forces first, later we have measured distances and we have placed the distances in the brackets. In the same way we are going to do here. So at point B, what are the 4 forces? 60 bracket plus 70 bracket plus 40 plus 30 multiplied with the distance. So right, so take point B, and from point B, and let us choose a different color. Okay, fine. From point B, let us go for each and every force individually. So what is the distance between the force 60 newtons and B? B is the point which is directly lying in the force 60 newtons. B is the point directly lying on the force 60 newtons. So let us write the line of action of force. So this is the line of action of force, and what would be the distance between the line of action of force and the point where the moment is required? So the distance is 0. So it is obvious that the moment obtained at B when 60 newtons is applied is 0. Right? In the same way, let us go for the second force, 70 newtons. B is here, and right. Yeah, and this is nothing but force 70 newtons, in which point B is lying inside. See, the 70 newtons force is passing through the point B. So it is must that there is no distance between this point and this line of action of force. The point is directly lying inside the line of action of force, which is directly meaning us there is no distance between them, right? So let us write this thing. It is 0 again. And coming to the 40 newtons force, so this is point B and this is 40 newtons force. So what would be the distance between the two? Let us draw the line of action of force. This is the line of action of force, and point B is somewhere here, and certain distance of 2 meters is being maintained between the point B and the line of action of force of this force. So the distance is 2 meters. So let us write inside the bracket 2 meters. In the same way for fourth force. So what is the fourth force? 30 newtons. So here is the point B, and 30 newtons force is acting somewhere here with a distance of 2 meters. 30 newtons. So 30 newtons, it is separated by a distance 2. Let us write it again. It is 2. Let us calculate this. So equals to 60 into 0, it is 0, plus 70 into 0, it is 0, plus 40 into 2, it is 80, plus 30 into 2, it is 60. So finally the answer comes out to be 80 plus 60, that is 140 Newton meter. This is nothing but the moment obtained at the point B with the application of all these forces. Right. Let us move to another page to obtain moment at another point C. So before doing this, we have to paste the question here, pinch it, drag it. Let us start it. Moment at point C. You can see, you can clearly see in the picture. Let us write all the forces again. 60 plus 70. What happened? Wait a second. 70 plus 40 plus 30. What are the total moments acted at each and every point at point C? So with the force of 60 newtons, what is the impact? So here is the C, and the 60 newton force is acting in this direction. Let us draw the line of action of force. This is the line of action of force. Also within the line of the force, also the line of action of force passes. So from C to this force 60 newtons, there is a distance which is separating them. So it is 2 meters, which is perpendicular distance, right? Which is perpendicular, that is 2 meters. So let us write 2 inside the box. 2, and let us take 70 newtons. And where is the point C? C is somewhere. C is inside here, right? Have a look into the picture. The same I am drawing here to make you understand. I am taking each and every element separately. Let us draw the line of action of force. So this is the line of action of force, and the point C is also lying inside the line of action of force. And is there any distance between the two? No. So there is no distance between the two, so the distance comes out to be 0. So 0. And coming to the force 40, and this is the force 40, and this is the force C. This is the point C. Here itself the point C. Let us try to draw the line of action of force. This is the line of action of force. So for this line of action of force, is there any distance between point C and the line of action of force? No, it is 0. So the same 0 again, let us write inside it, same 0. And is there any impact by this 30 newtons force? So C is here and 30 newtons force is acting like this, where it is 40 newtons force, it is having 0, here it is 30 newtons. So it is separated by a distance of 2 meters, right? 2 meters. So 2 meters is the distance. So 2, let us try to calculate it. 60 into 2, it is 120. 120 plus 0 plus 0 plus 30 into 2, it is 60. Totally it comes out to be 180 Newton meter, and this is nothing but the moment acting at point C with all these 4 forces. Let us go for point D. Yeah, paste it, pinch it, grab it. Right, let's do it. So moments at point, okay, wait, moments at point B, that equals to 60 distance plus 70 plus 40 plus 30, right? Let us try to find out the distances. So the point D is here, and the force of 16 newtons is passing like this, and whereas this is the 30 newtons force, so 16 newtons is passing like this, and the line of action of force 16 newtons is like this, and from the point D to the line of action of force of point 16 newtons, of the force 16 newtons, it is 2 meters. So let us write 2 meters inside the bracket, 2, right? And is there any impact shown for the force 17 newtons? So D is here and the 17 newtons is passing at a distance of 2 meters from the point D. It is at perpendicularly separated with a distance of 2 meters. So it is D. The distance is D. The distance is 2. Coming to the fourth force, third force 40 newtons. Here it is D, it is 40 newtons, and this is the point D. So is there any distance between the line of action of force of the 40 newtons force and point D? No, there is no distance at all. The point is directly lying inside the force, line of action of force, so it is 0. And for 30 newtons, so for 30 newtons, this is point D, in which it is lying inside the line of action of force of the force 30 newtons, right? Is there any distance? There is no distance in between maintained, so it is 0, right? So let us try to calculate it. 60 into 2, it is 120 plus 70 into 2, 140, and 40 into 0 plus 30 into 0, it is obviously completely 0, so no need of writing it. So 140 plus 120, it is 260 Newton meter. It is nothing but the total moment obtained for point D. For point D, total moment obtained for point B. So I hope this video has helped you in understanding this problem, and I hope this will give you a clear clarity on what is moment, on the definition of the moment, right? Thank you so much.